but I don't. So I know you have seen it, for example, going through the upper slit, and from that you made that and that prediction. So this consistency is really only if I'm already certain that you saw something and made a conclusion based on that. Then I can also make this conclusion.
Even if it stops being certain later that I made this, that I saw this?
If it's still certain at the time when I make this conclusion. So if I make a conclusion about what I'm certain you saw and still know now at the time when I make the conclusion, then I would say I can now make that conclusion as well. Maybe the conclusion is about something that happens later, but I do the reasoning at the time. So that's why these timings are really important in these discussions. So many people disagreed before they saw the timings, and then they say,
argue about this later, I guess.
Yes, maybe,
it seems
yes.
like it's an indefinite problem. But just like at the very end, you didn't even show us. You said, okay, quantum mechanics predicts 1/12.
yes.
Right, so that means quantum mechanics, I know what it predicts, done. So it has to be one of the other two that's wrong.
Oh, no.
Right?
That's why, again, the timing is important, because quantum mechanics predicts something about this time here, and it predicts something about the correlation between this time here and this time. So we use just quantum mechanics to make different statements. And they're all valid statements. So in some way, of course, if you now tell me you think this consistency is wrong, that's fine. But I don't think the quantum mechanics, like this conclusion about the probability 1/12 is kind of more valuable than, for example, the conclusion that if this guy sees Z plus 1/2, then this other thing is tails. This is equally, I mean, I use quantum mechanics in somehow the same way. It's not that, because, I mean, some people have this view that if I do the outer perspective, this is the right one or so. Yeah. But that's a particular view. You can, of course, take the view, which some people do, and say that if there is a contradiction in what quantum mechanics tells us, then it's always the outer one that is correct. That's what the Bohmians do, for example. Because they actually also run into the contradiction if they use Bohmian mechanics from the point of view of F bar. So if they would just say F bar sees the world around her and uses quantum mechanics to that, but doesn't include herself into the description. That's, of course, how we use a theory. I mean, I never include myself. And now the Bohmians say, okay, this conclusion that F bar would make contradicts the conclusion they would get if they take an outside viewpoint. And now they postulate that always the outside viewpoint is the correct one. But you need such a postulate. And if you do it, then you're fine. But this is not part of, let's say, quantum theory that tells me I should always take God's view, and I wouldn't even know how to do it, because then if everything is quantum, I don't have a system with which I could measure. But you could add such postulates, and if you add such a postulate, then this would be like the correct thing, and all the other things that are inconsistent with it would, by definition, by this postulate, be wrong. So that's a possibility indeed. That's probably your approach, if I understand.
No, I'm not willing to say that the conclusions made earlier on are wrong. I'm just saying, I guess I'm saying the consistency is wrong.
Yes, that's.
I shouldn't be reasoning about those because they didn't really happen.
Yes, yes. That's. I mean, indeed. I mean, one must be.
Exactly like the reasoning
yes.
that I saw the photon. One of the photons must have gone through one of the slits because that's how photons work. You know, have you seen the Ashcroft experiment?
No.
Remember this? I think it captures maybe some large part of this, but maybe not all of it. So it's an idea where there's a two-slit experiment, or maybe a mini-slit experiment, so it gets very. No, I guess it's two is better. And then you go to one of the places where on the pattern that you see on the slits, where it's very likely a photon will hit. And you put a lens there aimed at one of the slits, and then, like, if you're looking through it, you can just see that the slit was there. So somehow you can conclude retroactively that it must have come through a slit, even though it wouldn't have happened. It wouldn't have gotten to that point on the pattern.
Yes. But maybe one important thing is, in this experiment, I mean, there's a difference between saying, I do a double slit experiment and I know the particle went through one of the two slits, but I don't know which one, but let's assume it went to at least through one.
I remember what it is. He puts a screen, instead of the place where you normally see the pattern, he puts a screen there, blocking off all the places where there's no probability of the photon. And so then you can reason that past the slit, because it made it through the screen, and I see something with my lens that's farther behind the slit, then it must have gone through both
slits must have been open.
Yeah, both slits must have been open.
Yes.
And in fact, it must have gone through both of them because there was an interference pattern that allowed it to go through my screen.
Yes.
But I'm looking at which slit it went through, and I see exactly which slit it went through.
Yes, but you cannot do both
But I
at
just
the
did
same
both.
time.
But I reasoned
You
that
didn't
earlier,
do
but
both.
when it went through the screen, it must
Yes.
have...
Yes, but you changed the experiment by going there and looking.
No,
I mean, you
I-
cannot see both the interference
But
pattern.
no, the point is that I think the correct interpretation of it, and I don't know which of these things this violates, but and the correct interpretation of that is that, yes, it went through both, and yes, it went through the interference pattern, but the interference pattern is just such that it'll look like it went through one of the slits. And that's all totally consistent.
Okay.
And so you
So-
end up reasoning things that... it
Anyway,
went
I mean,
through one
at the
slit,
end-
And it didn't go through... and
Of
it
course,
went through both slits.
at the end, I agree with you. I mean, the whole point is the consistency. I mean, if you accept Q quantum mechanics, then probably the consistency must be wrong. So in that sense, I agree with you. And this is just a way to actually demonstrate that. But maybe you should write down one. Or yes, maybe. But I should just say, so the consistency, if one says it's wrong, then it would be good, maybe you have at least a weaker replacement, because to give it up completely would, in my opinion, be very unsatisfactory. And I would love to see a weaker version which doesn't run into the contradiction, but still allows us to do the things we do in daily life, so to speak.
Well,
That would be a nice
say-
challenge to come up with such a thing.
If everybody's dephased in the same basis, then you can reason about it.
No, this doesn't work. I tried that. We can discuss that. Yes, this doesn't work here, unfortunately. So the trivial solutions don't. But we should discuss it. But there's hopefully now time to do it. So thanks for your attention.